Imagine this, you have spent a month verifying a brand new USB controller. Every simulation passed, coverage is above 98%, everything looks perfect. Finally the chip gets fabricated. It reaches the customer. But the moment they plug in a new USB flash drive, nothing happens. Instead, the screen shows a frustrating message: USB device not recognized. No hardware failure, no software bug, just one teeny mistake in the USB protocol during the enumeration process. And because of that single bug, thousands of laptops fails to detect USB devices. The entire product launch gets delayed, costing the company a huge amount of time, money and reputation. Now imagine being the verification engineer who catches that exact bug before tape out. That's the power of protocol verification. Hi everyone, welcome back to Logic Verify. If you are preparing for design verification, interviews, learning system Verilog, and UVM, or simply want to understand one of the most important communication protocol used in modern electronics, then this video is for you. By the end of this video, you will understand how USB actually work, why USB was designed the way it is, the evaluation of USB 2.0 to USB 3, USB Type-C and USB 4, and finally how USB is verified in the real industry using UVM, system Verilog assertion and functional coverage. We will start from the absolute basic. So even if you never studied USB before, don't worry. Let's begin our journey into the world of universal serial bus. So let's start from the most basic question. What exactly is a USB? USB stands for Universal Serial Bus. As the name suggests, it was created to provide one universal standard for connecting different electronic devices to a computer. But why USB even needed? If we go back in 1990s, computer had a different port for almost every devices. A keyboard used a PS2 port, a mouse used another PS2 port, printer used a parallel port, modem used a serial port, and cameras often required their own dedicated connector. Every peripheral came with a different cable, making computer complicated to use. To solve this problem, several technology companies came together and developed USB. Their goal was simple: one common interface that could connect almost every peripheral. Today, USB is everywhere. When you are connecting keyboard, mouse, pen drive, webcam, printer, smartphone, gaming controller, or an external SSD, chances are you are using USB. But USB is more than just a cable. It provides two important functions simultaneously. First, it transfers data between devices. Second, it supplies electrical power. That's why your smartphone can charge while also transferring files through the same USB cable. USB also introduced several features that made it incredibly popular. The first is plug and play. You simply connect the device and the operating system automatically detects and configures it without requiring manual setup. The second is hot plugging. You can connect or disconnect USB devices while the computer is running. There's no need to restart the system. Another important feature is backward compatibility. For example, even if your laptop has USB 3.2 port, you can still plug in an older USB 2.0 pen drive and it will continue to work correctly. These advantages are the main reason why USB has become world's most widely used communication interface. Now that we know what USB is, let's see how it has evolved over the year. USB has been continuously evolving for more than 25 years. Each new version increased speed, improved efficiency, and added new capabilities. Let's quickly go through the timeline. The first widely adopted version was USB 1.1, introduced in 1998. It supported a maximum speed of 12 Mbps, which was called full speed. At that time, it was mainly used for keyboard, mouse, and printer. In the year 2000 came USB 2.0, one of the most successful USB version ever released. It increased the speed dramatically to 480 Mbps, known as high speed. This made pen drive, webcams, external hard drive, and many consumer electronics practical and affordable. As the storage device became faster, USB also needed to improve. In 2008, USB 3.0 was introduced with a maximum speed of 5 Gbps. This version was called Super Speed USB. Unlike USB 2.0, USB 3.0 is added dedicated transmit and receive differential pair, allowing full duplex communication. Later came USB 3.1, which doubled the speed to 10 Gbps, followed by USB 3.2, capable of reaching 20 Gbps using multiple high-speed lanes. Finally, we have USB 4, which support speeds up to 40 Gbps, and in newer revision even higher. USB 4 can also carry PCI Express, DisplayPort, and USB traffic simultaneously over the same cable using a technology called tunneling. One important interview point to remember is that USB 3X is not simply faster version of USB 2.0. Its physical layer, architecture, and communication mechanism are significantly different. We will understand this difference later in the video. Now that we have seen how USB evolved, let's understand how USB devices are actually connected. To understand USB communication, we first need to understand its architecture. USB follows a tiered star topology. As the center of the topology is the host. The host is usually a computer, laptop, or smartphone, and it controls the entire USB communication. This is a very important point. Unlike some other communication protocol, USB device cannot start communication on their own. Only the host can initiate communication. Whenever data needs to be transferred, the host first sends a request and only then does the device respond. This is why USB is also known as host control protocol. Now let's look at three main components. The first component is host. The host detects newly connected devices, supplies power, assigns address during enumeration, schedules data transfer, and manages all communication on the USB bus. The second component is the device. A USB device can be keyboard, mouse, pen drive, printer, webcam, speaker, or any peripheral connected through the USB. A device simply waits for command from the host and responds accordingly. The third component is the hub. A hub allows multiple USB devices to connect through a single USB port. Instead of communicating directly with the computer, devices communicate through the hub, which forward the packets between the host and connected devices. An easy way to remember this architecture is by imagining a classroom. The teacher represents the host. The student represents the USB devices. The student don't start talking randomly. They answer only when the teacher asks a question. Similarly, USB device communicate only when the host initiate communication. This host control architecture makes USB communication organized and prevent collision on the bus. Now let's look at the different physical connector used in USB. So far we have discussed the protocol. Now let's look at the physical connector that carry USB communication. Over the year, USB has introduced several connector types, each designed for different application. The most common connector is USB Type A. This is the rectangular connector that we have all seen on our desktop computer, laptops, televisions, charger, and power bank. Type A is usually found on the host side and is not reversible, meaning it can only be inserted in one direction. The next connector is USB Type B. It has a square shape and is mainly used for printers, scanners, and some industrial equipment. Then came Mini USB, which was commonly used in older digital cameras and portable media devices. Today it is almost obsolete. After that, micro USB became extremely popular, especially in Android smartphones, Bluetooth speakers, and power banks. Although smaller than mini USB, it was still not reversible and had limited power capabilities. Finally, we have USB Type-C, which is the modern standard used in today's smartphone, tablets, laptop, and many other electronic devices. USB Type-C is reversible, meaning it can be inserted in either direction. It supports much higher power delivery, faster data transfer, and can carry multiple protocols such as USB 2.0, USB 3x, USB 4, DisplayPort, and even Thunderbolt. However, here's an important interview question. Many people think that if a device has USB Type-C connector, it must support USB 3.2 or USB 4. That is completely incorrect. USB Type-C only defines the physical connector. The protocol running through that connector could be USB 2, USB 3.2, USB 4 or Thunderbolt, depending on how the manufacturer has designed the devices. So always remember this difference. USB Type-C is a connector, not a protocol version. And that's one of the most common misconceptions asked in USB interviews. Now that we have understood the basic of USB, its evolution, architecture, and connector types, we are ready to move deeper into USB communication. In the next section, we will study how USB 2.0 actually transfer data over the D plus and D minus lines, understand NRZI encoding, bit stuffing, and the complete enumeration process, the foundation of many design verification interview questions. For now, that's the end of this video. This is Logic Verify signing off.